For instance, if y is equal to f of x, and y is a function of x, we can explain the relationship between y and x on the coordinate plane. For instance, let's draw this. We have the x-axis and we have the y-axis. So this is the x-axis and this is the, so that's y-axis and this is the x-axis. So for instance, you have a curve. So let's define the secant from 2 points. Let's name this point P and let's name this point Q on the secant. Let's name it point Q. Let's name this point Q. Now, if this is point Q, of course, P will have its own coordinate. Let's say coordinate x, y. Let's say this is the x value of P. The coordinate of P is, let's name it here, x, y. And what is our y? Our y is f of x. So we write f of x here as coordinates on y. Then coming to this point, Q has its own coordinate. Let's name this our x2. Let's name it x2 because it is a different value for this component of x that is here. But then, what will be the x2? This will be, let's name this x2, let's name this one x1. So if you draw this straight line, of course, on the graph, the lines are continuous. So you have something like this. And then how about the y-axis? This is for y-axis. For y here, we have f of x. Then for second value of y, as the upper value, we have y2. Alright, so if you look at the distance from x to x2, there is a change in x. Well, we can explain that from using a straight line. For instance, if here is 0.2, here is 0.5, the gap between 2 and 5 is 3. So you can get that by doing 5 minus 2, which will give us 3. So this 3 is known as the change in y. So change along that axis will be 3. So here, the gap from here, from this point, is known as the change in x. So for you to get to the next value, you are going to add 2 plus the change in x, which is 3. You get to 5 because, of course, the change in x is 3. So here, for us to get the x2 will now be the change in x. So the coordinate of q here will be start with x plus the change in x. That's for the first one. And then since the first coordinate here is f of x, the second coordinate, let me explain that to you here. You have x, you have the function y is equal to f of x. Then if you have f of x equal to, for instance, there's a function 2x, what goes into this bracket means you are going to substitute the value for what you have on this other side, which is 2 times 2. So here we had x, then it was f, y was what? F of x. Then the moment you have x plus dx, it means that x plus dx is going into the bracket. That means x plus dx goes into the bracket. So what you have here will be fx plus dx. So this will be now be fx plus dx. Okay, so let's proceed. Now, to get the gradient, of course, when you are differentiating, you come to a point that the gradient m of the line is given by change in y all over change in x. So the change in y over change in x gives us the difference in y all over difference in x. That's what we mean by dy and dx. So the difference in y means you have y2 minus y1 all over x2 minus x1. So our dy dx will now be equal to our y2, which is f of x plus dx, f of x plus dx minus our y1. Here our y1 is f of x. We have f of x all over Then x2 here is our x plus dx, then minus x1, which is x itself. So here you see x minus x is equal to 0. So what we are left with here is having our dy over dx to be equals to f of x plus dx minus f of x all over dx. Now you see this is, we have it as the limit of a function, because as the point q approaches p, you see that there will be a decrease in dx. There will be a decrease in the difference in x. It will decrease until you get to a point that the difference in x will tend to equal to 0. So as the x tends to 0, we call it the limit of a function. So the limit of a function is that as the limit of a function, dy dx, as the x tends to 0, will be equal to our dy dx, and that will be defined by f of x plus dy minus f of x all over dx. So this right here is the format that we have for differentiation. If you are differentiating from first principle, this is the format that you have it in mind for differentiation. Now let's look for a function and differentiate. For instance, maybe you have a function like f of x equal to y squared. So for instance, let's differentiate from first principle. If y is equal to f of x and is equal to x squared, let's find our dy dx, where f of x is a function of x, y is the function. Now we have our dy dx, which is takes the format of fx plus dx minus f of x all over dx. Alright, so what we are going to be doing is, we take y, you say f of x, which is f of y, is equal to x squared. So let's start with the first one, which is f of x plus dx. We'll be taking it one after the other. F of x plus dx, the first thing on our format, if f of x is x squared, it means that what is in this bracket is x, and then it defines squaring what is inside of the bracket. So f of x is equal to x squared. That means you are squaring whatever comes into this bracket. Now what's in this bracket is x plus dx, so it means you square x plus dx. So this will be equal to x plus dx all squared, and then the moment you square this, you have it as x plus dx times x plus dx multiplying x plus dx. So by expansion, we have this function as x squared plus 2x dx, then plus dx all squared. So this is f of x plus dx. Now the next thing that comes is our subtracting f of x, as minus f of x. So we write it as f x plus dx minus f of x. And what's our f of x? Our f of x is x squared. So it means we are subtracting this expression. We are subtracting x squared from this expression. So that goes x squared plus 2x dx plus dx all squared minus f of x, which is x squared. So f of x is x squared. So from what you have here, x squared minus x squared is 0. So we are left with 2x dx plus dx all squared. Okay, so now the next phase is by dividing the x. Dividing by dx, you divide the expression by dx. We are through with the numerator, which is f of x plus dx minus f of x, and you divide the numerator by dx. So this gives us f of x plus dx minus f of x all over dx. So this gives 2x dx plus dx all squared all divided by dx. So of course we can split this into fractions, or you can factorize it using dx. You have dx as a common factor. Here you have 2x plus dx in bracket all divided by dx. So this will be dx dividing dx, and this gives us 2x plus dx. Now our dy dx is a limit of a function where dx tends to 0. So you can say that our dy dx is the limit of a function f of x plus dx minus f of x all over dx, where dx tends to 0. So there will be a change in dx till the dx tends to 0, and if dx tends to 0 we have 2x plus, it gets to a point where dx tends to 0 and it becomes 0 plus 0. So therefore it means that dy dx will now be equal to 2x. So if we differentiate y equals to x squared, where y is a function of x, you have 2x. So you can test this using the power rule formula. So using power rule formula, if y equal to x squared, so dy dx will be 2 times x into 2 minus 1, which is 2x raised to the power of 1, which is equal to 2x. So this is known as the power rule formula. So this is how you differentiate using the first principle, that is differentiating from first principle. All right, thank you.